Anyone?
Figure out how to get the vertex and the axis.
Exactly. So we took an equation in standard form. Now, standard form means something like 2x squared plus 8x minus 5. That's standard form. And we figured out, well, first of all, we knew what shape this was because it's a squared, it's parabola. So we wanted to know what its vertex, axis of symmetry, and direction of opening was. Right? Okay, so how do we do that?
Negative b over 2.
So x equals negative b, so negative 8 over 2a, 4. So we get x equals negative 2. And that is your axis of symmetry. So if you haven't yet memorized x equals negative b over 2a, get it memorized, right? That's how you get your axis of symmetry. And then that also gives me the x part of my vertex. And then how do I get the y part? Sandra? I plug it back into the equation. So carefully, 2 times negative 2 squared plus 8 times negative 2 minus 5. Right? And then if I need a calculator to do that, I can use it, but I gotta be really careful. These parentheses are important. Negative 2 squared is 4 times 2 is 8 minus 16 minus 5. So what is that? Negative 13. And then this one I could have done first because to tell which, this is direction of opening, and to tell which way it opens, all I have to do is look at that number, right? Positive means up. If that had had a negative out there in front, it would be down. All right, everybody got that? So that was one huge piece of what we learned yesterday. The other huge thing we learned yesterday was how to write our own equation if we're given the vertex, like let's say 5, negative 1 is the vertex, and another point that the parabola contains, like 2, 1. Okay? So we're going to write the equation of the parabola. We know its vertex, and we know some random point that it contains. All right, who remembers this? This is another big piece of yesterday. Who remembers what we do here? Declan?
You would build the frame of something. So it'd be y equals, then leave a space for number, parenthesis, x, and then minus the 5 times, and then minus 1.
Now, there's the framework of the equation. There's one thing missing from it, though.
Square.
We gotta have the squared. Because if we don't have the squared, it won't be a parabola, right? So we gotta have the squared in there. Now, does everybody understand? Look at it. Make sure this is settled in your head. Does everybody understand why he said x minus 5 in the parentheses and then minus 1? Keep in mind, the vertex is right 5 and down 1, right? Well, I don't know if it opens up or down, but it's over here, right 5 and down 1. So that means my picture, which used to be at the origin, right, x squared used to be at the origin, it's gone right 5 and down 1. Well, if I want to go right, don't I have to put x minus in the parentheses? We know that from before. And then down would be minus 1. So this says right 5, down 1. Now, that's the framework of the equation. That's the beginning. That's what you have to start with. Now we got to figure out what this number is. Okay, how do we do that? Scout?
You take the contains one and you set the x and y equal well, you plug them in.
Exactly. And I know this sounds crazy, but make sure that you're putting 2 in for X and 1 in for Y. So 2 goes in for X and 1 goes in for Y. Because that's what that point is. Okay, then 2 minus 5 is negative 3 squared is 9, so this is 9n. So we'll add 1. We very often get crazy numbers when we do this, and it's not a problem at all. Because now all I have to do is rewrite my equation with that 2/9 out in front. Okay, we got that, folks? Anybody have a question about either one of these? Guess what we're gonna do our next class? We're gonna do one of each of these, right? So I'm gonna give you an equation like this, and I'm gonna say, what are these? We just reviewed that. Direction of opening is easy, nobody misses that one. It's either positive or negative. If positive, it's up, negative, it's down. This number right here where I'm pointing. Then we find our axis of symmetry, our x value, being negative b over 2a. And then we plug that into the equation, and that gives us our y value. Right? And then this guy over here, a little harder, I give you the vertex and some random point. Use the vertex to build the framework of the equation. So the framework of the equation is always going to be something like this. Right, with a plus or a minus here, always going to be something like that. Now, these might not be pluses, I had to put something in there, they might be minuses, depending on which way things are going. So, remember that the first number is the x, and if it's going right, it's minus, if it's going left, it's plus, and then the second number is the y, if it's negative, it's down, positive, it's up. Then, once you've got that framework built, then you take the other point and plug in your x and y and figure out your n. Now, there are some of those in your notes. We did them yesterday. Go back and redo them if you need more practice. Right? Okay. All right. So now we're moving on to section 2.2. I don't know if any of you are around tomorrow morning. I will be here for office hours, but because I am doing standardized testing and PSAT testing in a different classroom, it would be helpful if you're gonna come in tomorrow that you get here early. They'll come rolling in at 8:25 because I'm probably done and moving to whatever room I'm going to. Okay? All right, so in our notes, 2.2. A and B are the core. I'm looking on 2.2. This is page 16 of my notes. A and B are the core of the whole thing. A says write an equation for y varies directly as x. There it is. That is direct variation. So in a minute, we're going to be doing some of these other ones. And if it says varies directly, then that is what your equation is always going to look like. B says varies inversely. Inversely is this. So you're going to build an equation for every one of these problems, depending on whether it says direct or inverse. All right, so let's see how this works. C, P varies directly as the square of Q. So in other words, varies directly means it has this format, but instead of x and y, or y and x, it's p and the square of q, or q squared. If it would have said varies inversely, I would have put K over Q squared. D. M varies inversely. See how I set that up? M equals, and then since it's inversely, it's gonna be K over what? The sum of A and B? So it's either gonna be K times, or it's gonna be K divided by. Height varies directly as weight. And then F is a little bit tricky because it doesn't use either word. Is proportional to is the same as varies directly. So is proportional to means the same as varies directly. So Y is proportional to X means Y varies directly as X. And then G, rate is inversely proportional or inversely, varies inversely to distance. Now, just to make sure you have some sense of what we mean by varies directly. I love bananas, so every time I go to the store, I buy bananas. If I buy a little bunch of bananas, I pay a certain amount of money. What happens if I buy a bigger bunch of bananas? I pay more money. As my bananas go up in pounds, my money goes up, right? That's direct variation. Both quantities, pounds and money, go up or down together. More bananas, more money. Less bananas, less money. Let's say I get my car in the morning and I drive to school at 30 miles an hour. Okay, it takes me a certain amount of time to get here. And let's say tomorrow I drive exactly the same route, but I drive 40 miles an hour. What happens to the time it takes me to get here? It goes down. So that's inverse variation. As my speed goes up, my time goes down. See the difference? So when we talk about things varying directly, we mean they're both going up or down together. When we say things are varying inversely, it means one's going up and the other one's going down. Okay? All right, so that's kind of what that is. All right, here we go. Number 2A. Temperature is directly proportional to volume. Stop right there and write the equation. Temperature varies directly as volume. Isn't that my equation? Because when they vary directly, it's K times. So temperature varies directly as volume. All right. Sentence 2. If the temperature is 70, the volume is 30. Now, do you see what I did? I took the equation that I wrote and I plugged in, the temperature was 70 and the volume was 30. I plugged that in. Now, what am I going to be able to do with this equation? I'm going to be able to solve it and figure out what K is. So K equals 70 over 30, which is 7/3. And then the last sentence says, find the temperature if the volume is 20. Find the temperature if the volume is 20. Now, that equation might look a little scary, but what do we know? Don't we know that number? So T equals 7/3 times 20. which is 140 over 3. I'm just gonna leave that as a fraction, but if you're typing it in on your calculator, you'll get some decimal. Now, at first glance, these problems seem hard, but they're very easy if you take them one sentence at a time. All right, so now next. Volume varies inversely as pressure. So what does that equation look like? Volume varies inversely as pressure. When they vary directly, we multiply, K times whatever. When they vary inversely, we divide, K divided by whatever. So start with the first thing they said volume, so V equals, and then K over P. All right. If the volume is 200, the pressure is 40. So what does that allow me to do now? So I can figure out that K equals 200 times 40, 8,000. Now, that's this number right here, right? So I know what K is now. Find the pressure. I'm finding the pressure when the volume is 950, but I know K is 8,000. Does this equation make sense to everybody? The volume is 950. I don't know what the pressure is, but I know K is 8,000 because I already figured that out. All right, how do you want to solve that equation? That one's a little bit harder to solve. How do you want to solve
You
it?
multiply out the P. and then
Multiply
divide by
out the
950.
P. Get rid of the fraction. So 950P equals 8,000. Multiply both sides by P. So 950P equals 8,000. And then
Divide by 950.
divide by 950. That I do need some help with. So P is
8.42.
what?
8.4.
8.4. Is that what everybody has? Now that, my friends, is the end of section 2.2. It's very, very short and sweet. So that homework will be due on Friday. So 2.2 is due on Friday. Feel free to turn it in with 2.1. It won't take you very long at all to do. Okay? Well, now we're gonna do my favorite part of the chapter. I love graphing polynomials. It is so fun. So here we go. We are gonna graph this polynomial without a calculator. Now, the good news is, it's exactly the way we want it. We want it to be in the factor, so don't FOIL it out. You're not gonna do any multiplying, at least not right now. No multiplying. We're gonna graph it just like this, okay? So here's the first thing I want you to do. On your grid there, I want you to plot 3 points, right here on the x-axis, 3 points. Does anybody have a guess, looking at the problem, where those 3 points are going to be? Alex?
1, 2, and 3.
Very close. Definitely 2, and definitely 3. But it's actually -1 is where that one is. That makes sense to everybody? So think about it like this. If this were an equation that you had to solve, x plus 1 equals 0, you would set them equal to 0, and wouldn't you get -1? And +2 and +3. That's where the dots go. Now, those dots are called the x-intercepts. They're on the x-axis, or the zeros. Their technical name is the zeros. Okay. Now, remember I told you your BFFs were never gonna leave you. They aren't. I want you to think about, if I were gonna FOIL this out, which I'm not, but if I were, I would have x cubed. Would you agree with that there'd be an x cubed? And you all know what x cubes look like. Now, this one's gonna be modified a little bit, but basically, an x cubed starts down here and squiggles its way and ends up here. That's the way cubes go, period, always. So this thing, because it's a cube, is gonna start down here. There's the tail of it down there, just like right here. But because this one's got other numbers in the problem, it's not gonna just go straight up, it's gonna do some squiggling around. These 2 points have to be connected. So the curve is gonna go right through, and it's gonna come down and connect. Now, it's a calculus problem to know exactly how high it goes. We're not there yet, so we're just gonna take it up a ways and bring it back down. If I needed to know the maximum, I would have my calculator find it for me. But I'm just doing a quick sketch. So up it goes, down it comes. Now, guess what it does when it gets to this one? Well, it goes down, but it can't go down too long because it has to turn around and connect to this one. And then guess what it's gonna do? Head right up, just like we knew it was going to. There it is. Now again, I do not know exactly how high it goes or how low it goes, and I'm not concerned about that. I wanna see you sketching it from the bottom, coming up, down, and back up. Now B, would you say B is exactly the same thing? Yeah. I mean, different dots, obviously, but isn't the shape gonna be the same? Isn't that a cube? Alright, so you ought to be able to sketch this one. Where are the dots gonna go? Kaden, where are you gonna put your dots this time?
-4, 2, and -3.
Bingo. -4, 2, and -3. Now this one is also a cube. How do cubes always, cubes forever, are going to start down here and end up here. This is what cubes do. So I'm gonna start my picture down here. And then what am I gonna do when I get to this dot? I'm gonna go through it, connect down, go through it and connect up. Did you already have that drawn? This next one is a curveball. What's different about this next one?
It has 4.
C has 2 factors that are exactly the same. In other words, it has a squared in it. Now, what does that mean in terms of the picture? Well, first of all, there's only gonna be 2 dots, right? So I have a dot at -1 and a dot at 3. Does everybody follow that? Now, if I FOILed it out, would it still be an x cubed? So it's still starting down here. Now, here's the new piece of information for you. And I think this will make sense to you if you think about it. If I only had this, if I didn't have that, if I only had this, what shape would that be? A parabola. So what that means, guys, is that when the curve hits that point, it doesn't go through. it actually bounces off and comes back down. In other words, this isn't a real parabola, but it has kind of a parabolish shape. Whenever you have a squared factor, your curve does not pass through, it bounces off. Whenever that happens, it bounces off. Now, it's gonna bounce off, but at some point it has to connect up to this one, right? The points are always connected. So, what happens when it hits the 3? Then it goes through. Because it only bounces off when it has a factor that is squared. Everybody okay with that? Oh my, look at D, isn't this fun? Look at D. What is going on with it? Okay, it's gonna have 2 bouncing points, but there's something else that makes this problem different. It's gonna have dots at 2 and dots at -3, but this is not a cube. This is a 4th degree polynomial. It's called a quartic polynomial, because if you FOILed all this out, we have 4 parentheses, so x, so it'll be x to the 4th. Now, x to the 4th is not one of our BFFs. So I'm gonna give you another piece of information. X squared is a BFF, right? And how do x squareds behave? They start up and they're parabolas, right? Any even degree is gonna behave that way. So x squared looks like this, x to the 4th looks like this, x to the 6th looks like this, and so on and so on. If you are x to an even power, you're gonna start up and end up just like a parabola. If you are an odd power, like x cubed, you're gonna start down and end up. That's what odd powers do. So an x to the 5th starts down, ends up. Okay, so this you said was x to the 4th, which means it's gonna start up and end up, right? Now, there might be squiggling going on in the middle, but that's the end behavior. It starts up and ends up. So this thing is starting up here and coming down to this point. Now, what does it do when it hits that point? It's gotta bounce back up. And eventually it has to come down and hit this one. And what does it do when it hits that one? It bounces back up. So we've got some kind of W shape. The curve must start up here. It must bounce when it hits here. It must connect to this point and then bounce again. Oh my Lord, look at E. So, let's suppose you're doing this totally on your own. What are some of the things you think about as you're getting ready to do this problem? Alex? Okay, so if you multiplied it all out, it actually would be x to the 5th, right? What does that mean? That means it starts down and ends up. Now, again, I don't know what's happening in the middle, but this is the end behavior. It starts down and ends up. All right, what else are you thinking? That's very good. That's very good to think of. What else are you thinking?
It's gonna have 2 points that it bounces off of.
Okay, so it's gonna have some places in the curve where it bounces. So pick places that look like this. Alright, what else are you thinking? What do you have to get started? Gotta have your dots, you have your points. So you're gonna have one at -1, at 2, and at -5. Got it? Now, you already figured out it's gonna start down here. Because it's odd degree, x to the 5th. What does it do when it hits that point? Well, look at your problem. That point came from here. So what does it do when it hits that point? Goes right through. If there's no squared or anything, guys, it just goes right through. And then at some point, it must turn around and hit here. What does it do when it hits there? It bounces, comes down. Remember, they have to connect. So go up some distance and then come back down. What does it do when it hits there? It bounces back up. And that's exactly what we thought would happen, because that's what odds do. They start down and end up. You saw it?
Why did it bounce back up again at the end?
Anytime you have squared factors, it bounces. So that point came from this factor. X minus 2 gave you this factor. That one squared, it bounces. F, total craziness. What's going on in F? Now we have a cubed factor. So something's happening at 3, and something's happening at -1. Would everybody agree with that? What's the total degree of the problem? If we multiplied everything out, we would have x to the 4th, which is an even number, which means starts up and ends up. We don't know what's happening in between, but that's how it starts and ends, right? So I know it starts up here and comes down like this. Now, what does it do when it hits that dot? Now remember, that dot came from this parentheses. There's no power on it. So what happens when you don't have any power? You just go right through it. Now, let's back up. When we have a squared 0, our curve acts kind of like a parabola. When you have a cubed 0, it acts like a cube. So in other words, when it hits the point, it's a squiggle through it. Not just a straight shot through it, like this was. It's gonna squiggle through it. So that's a little bit hard to draw. I'm gonna kind of over-exaggerate it there. It squiggles through that point because that point has to behave like a cube does. And your BFF cube is that guy right there. Every even exponent, not just squared, but 4th, 6th, every even exponent is going to be a bounce off. Every odd exponent other than 1 just goes straight through. If this is a 1, you just go straight through. But if you're an odd, like a cube 5, 7, you're going to squiggle your way through that point. It's kind of hard to do. All right, let's look at G. We're hitting all kinds of new information. Let's look at G. What are some things you're observing or thinking about as you look at this problem? Okay, so you have counted up all the x's, and so the degree is 4. So it's x to the 4th, which means up, right? That's how evens do. But wait, wait. There's a negative in front of it. What do negatives in front of your equation do? Flip it. So a 4th should be up. Not this one, it's going to be down. Now, the 2 itself is not gonna impact your graph at all. It's gonna stretch it a little bit if I were actually plotting points. But for us, all we care about is the fact that it's negative. That's gonna turn it upside down. Negatives always turn us upside down, you guys, always, right? So, Quinn, you paying attention over there? Okay, this is big stuff. So I got my dots on there. I figured out it's x to the 4th, negative, which means down. So I'm gonna come up from the bottom. It's pointing down. Now, that point came from here. So what am I gonna do when I hit it? Go right through it, go straight through it. Nothing fancy, straight through it, connect to this one. Now that point came from here. So what am I gonna do there? Straight through it. That point came from here. Bounce off. And there it is. Now, look, in the next one, I don't want you to worry about the 1/3. Pay attention to the negative, but don't worry about the 1/3. See if you can sketch H. Did you put your x-intercepts on your picture? Please do that. Start with that, okay? Did you count up your x's to find out if you were even or odd? How many do we have? 6 x's altogether. Does everybody see that? That's even. So even, x squared, x fourth, x sixth, even is up. But not this time because there's a negative out in front, so it's gonna be another down. All right, so this is x to the 6th, negative, so it's gonna be down. So whatever's going on, I know that I'm coming up to this one like this. Now what happens when I hit there? That's not a squiggle because that came from here, didn't it?
You do the little like.
So that's gonna be a little squiggle, so I'm gonna start over again here because those squiggles are hard to draw. So there we go, I squiggled through. You kind of feel that in your wrist when you squiggle it. I always have a little hip action in there too. Squiggle that up. Now, it's gotta turn around and connect. What does it do when it hits there? Just goes through. Remember, if there's no power, it just goes right through. turns around, connects.
And bounces off.
That one came from here, so it's gonna bounce off. Would you agree with that? And there you go. Now, did anybody get that done before I started talking? And you have something that looks like that? Good, 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 good. One more thing, and then we'll do another review problem for our quiz tomorrow. One more thing that we're gonna do now is the backwards of this. So I want you to look, we're only gonna do the first problem, 2A, but I want you to look at the picture that I drew, and now you're gonna come up with the equation. So think about that for a second. Got a picture. That looks like this. So think of the equations we just graphed. What do you think at least part of this equation has in it or looks like? What do you think?
Negative.
Well, okay, we'll figure that out in a second, but you're right, because it's down, down, and down, down would be negative. How about parentheses? What are the parentheses gonna look like in this problem?
X minus 1.
X minus 1 from that one right there.
Plus 2.
X
Plus 2.
plus 2 and minus 3, and I kind of did these out of order. It doesn't matter, whatever order you want to put them in. Does everybody agree? X plus 2, X minus 1, X minus 3? Also, see this right here? What does that tell me?
Minus 1 squared.
That there's a squared on the one that has the X minus 1? Would you agree with that? Now Declan says there's gotta be a negative out here. Because down, down isn't normal, up is normal, down, down means upside down. So there has to be a negative there, but could there also be a number there? Could it be a -2? Could it be a -1/3? Could it be a -7/8? It could be negative lots of things, right? I have no idea what it is. I'm gonna call it in, and then I'm gonna think about what I did on my quiz, or the quiz I'm going to take. When I need to figure out what that first number is there, what do?
Plug a point.
I plug in a point. Some other point? Well, wait, do I have another point here? Yes. This guy is not a factor, boys and girls. Do not put this here. The only things that are factors are the x-axis dots. That guy is a contains point. My curve contains that point. So I'm gonna put 2 in for y and 0 in for all of the x's. Just like I do with my parabolas, only it's more, it's bigger now. So x is 0 and y is 2 for my contains point. So 2 equals n times -1 squared is 1. 0 plus 2 and 0 minus 3. This is a multiply. So what do I get when I multiply those?
6n.
-6
-6.
or -6n? So by golly, it is -1/3, isn't it? Because when I divide by -6, I get 2/6, which is 1/3. Now I'm gonna stop there because I'm gonna do a couple more reviews. So we got a couple more here we'll do, next time. Okay? Alright, if you got a sheet of paper, go ahead and get it out. I'm just afraid, again, there's a lot of time that's gonna elapse whole day off for most of you tomorrow. And I just wanna make sure that we're doing okay here. This is our chance to get a really good grade, hopefully. All right, so the quiz we take next time, which I think is Thursday, but I'm not positive. The quiz that we take next time is going to have 2 problems. One is gonna look just like this. It's gonna say find the vertex, axis, symmetry, and direction of opening. So what's the first thing you think about? It opens up. So we're not gonna miss those easy points, right? Positive number opens up. All right, what's the next thing you gotta think about? X equals negative b over 2a. So x equals negative 5 is my axis of symmetry, and negative 5 is the x coordinate of my vertex. And then what? Plug the x in, might need a calculator for this one. So 3 times negative 5 squared plus 30 times negative 5 minus 4. So 440. I got negative 79, but I did that without a calculator, so
Yes, that's what I got.
that's what you got too? Quiz problem number 1. Please don't miss that, right? You can do that. Got it, everyone? All right, quiz problem number 2 is a little bit harder. It's gonna say write the equation of the parabola. Vertex is negative 4, 2, and it contains the point, I don't know, 1, negative 1, okay? So where do we start? Right equation, so y equals.
Y equals in parentheses x minus, plus 4, minus 3. Is that right?
I don't know. Let's talk about it. First of all, she's setting it up sort of the way we want to. We want to have x in parentheses, right? Does this say we want to go left 4? That's what you want to do. You want to go negative 4. Is that what this
Plus
says?
Yeah.
Does this say go up 2? So we need this to be a plus, and then we need one more really, really important thing. We need a squared on that. Guys, this is a parabola. And what do you know about parabolas? X is squared, right? All right, are we good so far? If you need to, graph it. The vertex has to be left 4 and up 2. Is that what happens here? Left 4 and up 2, perfect. Now what?
Plug in the contains point.
Plug in the contains point, just like we did with our big equation we just finished. Plug in the x and y. So negative 1 and 1. One plus 4 is 5, squared is 25. Please don't add the 25 and the 2, they don't add together. 25 ends. So we're gonna subtract the 2 and divide by 25. So my answer is that. I put 3/25 negative in for the end value, and that's So are we clear on, we have a lot going on. We have assignment due Thursday, we have a quiz on Thursday, 2-problem quiz, and we have an assignment due on Friday. Right? Everybody's keeping up with all that. Okay,
That quiz is on Thursday.
I think so.
Oh wait, yeah,
I
because
think I
tomorrow's
see
a
that.
busy. My bad.
Yeah, tomorrow we don't have class.
That's right.
Tomorrow's a nothing day.
Forgot that today was Tuesday.
And I think Thursday's the day 3. So I see that day.
Thursday, I think we have like another class.
You have other class? I thought we only had day 3 classes.
I know it's like the super